Hello guys, today we are going to continue our content for this training. Actually, we are going to start with um, these topics. We are going to talk about arrays, and also we are going to talk about arithmetic operators. Then we are going to talk about something called logical operators. Okay. Actually, we are going to talk about arrays, which are some there are some lists. Actually, an array is a list of some values, or it contains some elements, and each element has its own value. Actually, uh, then we are going to talk about arithmetic operators and logical operators. Actually, there are some two more types of operators in our C++ language. Okay, we have something called relational operators, and also something called bitwise operators. So these are the four types of operators in C++ and C languages. Okay, these are the four types of operators. So you have these four types of operators to be used within uh, your code when you are dealing with some variables or some conditions you are working on. So you could use these four types of operators. These are our C++ types and categories of operators. Okay. Okay, now let's get started. Okay, let's start with arrays. Actually, uh, when I'm going to write something like this, actually, okay, so here I have declared an array. Actually, okay, my array is called also my array. Okay, that's its name. So I'm going to write here a name. Then I'm going to specify its size, actually, within the memory. So an array is considered as a portion or a part of memory. Okay, that's sequential actually, and it has a certain size. So here I have an array that's called my array with a size of 10 elements actually. So I'm going to write its size here within these two brackets, these square brackets. I'm going to write here its size. So this is the syntax to declare an array in C++ or C language actually. Of course, the array, which is a list of some elements, each element or every or all the elements of the array have the same type. So this array contains some elements with the same type, which is integer. Okay, so my array has some elements of the type int. Okay, so that's it. Now we are going to use some examples here. I'm sorry, arrays. We have four examples here actually I have prepared for you. This is our first example. Okay. Okay, here is our first example. I have declared an array here. Okay, and each and its elements have the type of unsigned integer. Okay, and it has 11 elements actually. Then I'm going to write the values for its elements. Okay, the first one is 0, the second one is has 1, 2, 3 until I reach 10. Okay, so these are the values I have written in my hand, by my hand, within this array actually. So here I have declared and defined my array actually. When I need to access a single element within my array, okay, So I'm going to use something like this. I'm going to write the name of my array and use also these square brackets, and I'm going to type the index of the element I want to access. Here I'm going to print uh, number 5, actually the element number 5 on my screen. So when I'm running this, okay, trans, I have 5 here printed on the screen because I have written 5 here actually. Okay, so that's it. When I need to access another element like 7, I'm going to write 7 here, and I'm going to run this. I have 7 printed here on the screen because I have written 7 here actually. There is a very important note actually, that we are accessing the elements of our array starting from 0, the indices starting from 0. So when I need the first one, I'm going to write here 0, okay, and I'm going to run this. It is 0. When I change this actually within my array like 66, then I run my program, I find that it prints 66 on my screen actually. Okay, so this is how I could access my array, how I could access each single element within my array. Actually this array is called single dimension, or it has a single dimension actually. It's called single dimensional array. So it's linear and it has its single dimension, no more dimensions. There is 11 there are 11 elements, and they are ordered one by one within the memory in a linear way. Okay, so I have my single dimensional array here, and I can access each element using this way. Okay, let's get back to our example actually. Here I have included this part, okay, to show you how I could use a loop, to use a loop with my array actually. So loops are going to be used frequently with arrays actually. I have declared a variable here that's called counter. I have called it counter. Then I'm going to use it, okay, to make a loop within or on my array actually. Here I'm going to print the contents of my array on my screen actually. So here I have used my cout statement. Then I have used this to print each element. I have written my array, which is its name, then these two brackets, these two square brackets, with this variable, which is counter, I have declared here. So now this variable is going to be incremented by 1 at each iteration, or at each repetition actually. So I'm going to print the elements from the index 0 until I reach the last one. Okay, let's run this program, and I have, this is the 5 printed from this single element actually. Then I have 0 until I reach 10 printed on my screen. Okay, so this comes from my array actually. When I change something here like this, okay, I have it printed on my screen also from 0 to 10, but this element is changed actually to 44. Okay, so that's it. This is our first example actually. Okay, let's get back to the examples and get this example. Actually, I'm going to show you how to fill your array, how to write certain values to your array, how to fill your array actually. Okay. Okay, this is our second example actually. I have declared an array here, which is called my array. Then I have declared a variable that's called counter. Now I'm going to fill my array. So here I have used another loop to fill my array with some values. Here I have used something like I have accessed each single element, that's my array, of the index counter, the variable I have declared here, starting from 0 actually. Then now I'm going to assign each element of my array to the value of the counter. So I have written something like my array of the index counter is going to equal the value of the counter. So I'm going to fill my array with the values that starting from 0 until I reach 10. Okay, then I'm going to print it back here. Okay, that's the same loop from the last example actually. I'm going to print it here back. So I think I'm getting the same result actually. I have 0 until I reach 10 printed on the screen. That's the expression I want to stress on. Okay, I'm filling my array with the values starting from 0 until I reach 10 using this formula here. I'm accessing each single element within my array using the counter variable, and I'm going to fill each element with the value of the counter actually. So that's it. Okay, the next example actually, I'm going to fill my array by the keyboard actually. The user is going to I'm sorry, yes, that's it. The user is going to fill each element, each single element with his keyboard actually, and using the screen. Let's try this. Here also I have declared my array actually. Okay, and now I'm going to fill my array using the cn statement, the input statement within the C++ language. Okay, I'm going to use this to take the input from the user actually. So the user is going to fill the array with some elements that he could determine actually, and then I'm going to print it back here within this loop. You see how you could use loops with arrays actually. Okay, let's run this. Here I have my program that waits for my input. Okay, I'm here actually. I'm going to fill my array. I'm going to fill the first element, which is which has the index of 0. Okay, I'm going to fill this. Let's fill it. 77, 99, 66, 0, 1, 3, 2, 4, 5, and 7, 8. Okay, so I got this. I got my array as shown here. What I have made as input, okay, I have got it as output. Okay, so this is the array that I have filled by my hand actually. So I could get its elements from the user actually using the keyboard of my device and also my screen to fill it. Okay, so that's it. It is the same example actually. Okay, but I have got the values for the array from the user. It's not like this. You see the difference? Okay, so that's it. This is from the past example, and this is the current example. Okay, I have got this from the user, and here I am filling this with something like predefined values. Actually, I know that counter is going to be incremented from 0 until I reach 10. Okay, so that's it. Now we are going to our last example. We are going to explain something that's called multi-dimensional arrays. Okay, we are going to explain this. So I'm going to copy this here. okay, and that's it. Okay, the example here is talking about something simple. Let's search about the chessboard. Do you know the chessboard? When you are going to play chess, you have a board like this actually. Okay, you see, I want to open this. Okay, it's here actually. You see this chessboard? You have something like this. Okay, you are going to play chess on something like this board. You have some squares here, and each square is going to be white or black. Okay, so have some white squares here, followed by some black squares here. Okay, so this is a white square, and this is a black square. This is a white square, and this is a black square, and so on. Okay, how could I represent something like this in my code? I want to represent something like this chessboard, this very chessboard, on my code. So here I have the multi-dimensional array to represent this chessboard actually. Okay, so let's get back to our code to see how could I represent this. Let's remove this for now. Okay, here I have declared an array that's called the chessboard. I have called it a chessboard actually, and then I have the specifications for the size or the sizes actually, the size values for this array. Okay, I want to represent an array that contains something like 8 elements or 8 rows times 8 columns. So I'm going to write this like I have 8 here times 8 here actually. Okay, you see this chessboard. You have 8 each row has 8 squares, and also each column has its 8 squares actually. So it's 8 times 8, which is 64. I want 64 elements. So I could write this in my code in this way actually. I could write this in this way. Okay, so I want to make a chessboard, or I want to make an array that represents a chessboard with 8 elements times 8 elements actually. How I could write some values that represent each square here? I'm going to write some values that represent these squares. Like when I'm going to say that this is a white square, so I'm going to write 0 for it, and this is a black square, I'm going to write 1 for it. So each white square is going to be represented by the value 0, and each black square is going to be represented by the value 1 for it. Okay, so I'm going to write this like where I am going to write something like 8 arrays actually. I'm going to write here I have 8. Okay, so I'm going to write something like I have 8 arrays, and each array has 8 elements. So let's write the first row actually, our first row. So here is our first row. This is our first row. Okay, the first array, or the first inner array. That's second one, third one, fourth row, fifth row, and so on. Okay, I have one more actually. Okay, so that's it. I have 8 arrays, or I have 8 rows actually. I'm going to represent this is chessboard, so I have 8 rows here. Okay, now I'm going to write some representations for each row. Okay, So these squares are going to be represented here. So I have the first one here is white, so I'm going to write 0, and this is a black, so I'm going to write 1. This is white, I'm going to write 0, and so on. So that's it. 0, 1, 0, 1, 0, 1, 0, and 1. So here I have made the representations of the first row. You see that the first row is going to be 0, 1, 0, 1, 0, 1, 0, 1, and also the third one is going to be 0, 1, 0, 1. So I'm going to copy this here. Okay. So I have represented some rows here actually. Then I'm going to represent the second row, which is going to be 1, 0, 1, 0, 1, 0, 1, 0. So I could also copy this, and I could make this starting from 1, and I'm going to end it with 0. So here I have it. Okay, second. So I've completed my multi-dimensional array. Actually, it has the dimension of 2. Okay, so I have completed my multi-dimensional array here, which represents my chessboard actually. Okay. Okay. Now I want to print it on my screen actually. Okay. So I'm going to use 2 for loops, something like an outer loop, an outer for loop, and an inner for loop. You could use any type of loops. You could use while, do while, any type actually. But it's more common to see that for loops are used with multi-dimensional arrays. Okay, it's too common. You could see this within the codes of many people actually. So I'm going to make something like a for loop here. It's an outer loop, and a second loop that's an inner loop actually. Okay, so the first loop or the outer loop is going to use a variable that's called I. Here I have used this variable. Okay, I have called it I, and the inner one is going to use some variable that's called J. Okay, so here I have used 2 variables for 2 loops actually. So that loop is going to be executed, and when the code of this loop is going to be executed actually, it contains another for loop within its execution. So this is going to be executed here, and you're going to be back to start from here actually. What I'm going to do is to print the contents of my array, of my chessboard actually. Okay, I'm going to access this like this. I'm going to write here the index or the indices of the element I want to access within my array. So I have used I here and J here to be printed on my screen actually. So let's run this. I have my chessboard printed on my screen actually, that way. Okay, when I see what happened here, I have my I variable, which is starting by 0 actually. So here I have I with 0 value. Okay, then I'm going here to have also J, which has 0 as its value. Okay, so I is 0 and J is 0. Now I'm going to print, okay, the element 0 and 0, chessboard with 0 here, and 0. Okay, so it's clear here. Then this loop is going to continue its execution actually for a second iteration. Now j is going to be incremented to be 1, so here I'm going to print the element 0 and 1. Okay, then j is going to be incremented to be 2, so I'm going to print the element 0 and 2. Okay, then 0 then j is going to be incremented to be 3, I'm going to print 0 and 3, and so on until I have finished this. Okay, until j reaches 7. Now j is going to be incremented, but now j is going to be 8, so j is not smaller than or less than 8, so I'm going to be finished, and there is a new line printed on my screen, and I'm going back to my outer for loop to get I incremented. Now I is going to be 1 actually, so I'm going to get to my inner loop again with j is equal to 0. Now it's a new for loop here, so here I have 1 and 0 printed on my screen. Then this for loop is going to be executed again, and j is going to be incremented to be 1, so I have the element 1 and 1 printed on my screen, and so on. Okay, 2, 3, 4, and so on. Okay, you see, this is the way you have access to your array, and you made 2 loops to access this multi-dimensional array to print its contents on your screen. Okay, so that's it. When I want to access a single element within my array, I could do this, something like this. When I want to access the element 1 and 3, I'm going to write something like this, the element 3 and 1, something like this, and so on. This is the way you could access your arrays, your multi-dimensional arrays actually. So it is a multi-dimensional array that has its dimension as 2. It has 2 dimensions here. You see, you represent rows and columns actually, so it has 2 dimensions here. So let's run this, and now we got our chessboard. So that's it. I think we have finished our arrays by now. Okay, so this is finished here, as I think. Now we are going to something new that's called arithmetic operators. Actually, you know most of these, but I'm going to explain them again and explain the new ones actually. Okay, so here you know all of these actually. This is plus, minus, multiplication, and the division. Okay, so you know all of these actually. We have used them. The new one is called the remainder operator, and also there are 2 more operators, and they are going to be 4 actually. The increment and the decrement operators. Okay, so this is for increment operators and this is for decrement operators. I'm going to explain all of these right now. Okay, I'm going to check about something here. Yes, it works here. Sorry for that. Okay, let's explain this actually. I have prepared an example here for the arithmetic operators. Actually, there is a typo here. It is not arithmetic, it is arithmetic. Okay, let's explain this. Okay, let's remove all of this and start using this simple program. Now I have declared two variables. The first one is called A and the second one is called B, and A is actually has 10 as its value, and B has its value as 5. Okay, so I have A and B. I'm going to use them. So here this is for addition operator. Okay, the plus. I have made this summation or addition operation here using A and B and the plus, this plus. Okay, this plus operator. It's very easy. So here I have A plus B equals to 15. 10 plus 5 is 15. The next one is for subtraction. Okay, so that's it. I have A minus B, which is going to be 5. So here I have A minus B, which is going to be 5. Actually this is minus, it's not plus. Okay, so this is 5 actually. Then I have multiplication. So let's run this, and now we have A times B, that is 50 actually. A multiplied by B is going to be 50. So now we have our division. Okay, A divided by B, that's A on B, is going to be 10 on 5 is going to be 5 actually. So now that's sorry, 2, I'm sorry for that. 10 by 5, sorry, 10 on 5 is going to be 2. Okay, so this is the division operator. Okay, that's it. Now let's get our new operator, that's called the remainder. It has something common with division actually. This is the remainder operator. Actually this remainder operator works like you have two values that's going to be divided by each other, and you are not going to present the result of the division. No, you are going to present that if this division has a remainder or not. So let's see something like this. Actually, if you have something like 10 with the remainder by 5, you get 0, because 10 is divisible by 5. Okay, this division could be achieved. Actually, you could divide 10 on 5 actually, so you could get 2 with no fractionals. Okay, there are no fractions here. Okay, so now you have the remainder of 10 by 5, that's 0. There are no remainders. But what if I have 11 here? So I got the remainder is 1, because I could divide 10 by 5 actually, but I have here 11, not 10. Okay, you see, so this is divisible by 5, but this is not. So I'm going to remind this is called the remainder. This is our remainder here. This is our remainder here. I'm going to show this to the user. This is the remainder actually. Also, if I have something like 3 with the remainder, I'm using with 5 actually. So 3 is not divisible on 5 or by 5. Okay, this division couldn't be achieved, so I have 3. That's the remainder here. This is a remainder for me. Okay, so that's it. Let's run this. I'm going to get 0 actually. So I have 0 here. The remainder is 0. But when I'm going to set this as 11, so the remainder is 1. So this remainder works on integer values actually. Integer values. So this integer values are going to be used to make the remainder operation here. Okay, let's try this. I have 2. Let's try this. I have 3. So that's it. This is the remainder operator actually. Okay. Let's get this back to 10 and continue. Okay. Now we are going to our increment and the decrement operators. So I'm going to show you something. This is called an increment operator. Okay, what if I have written something like this, a plus plus? Okay, so this plus plus is called increment operator actually, and it's going to increment the value of a by 1. So it is equivalent to writing something like a equals a plus 1. Okay, this is equivalent to this. A plus plus is equivalent to a equals a plus 1. So that's it. So here when I'm going to see out the value of a, okay, I have 11. It's incremented by 1 actually. So this is called an increment. Okay. Okay. I would like to add something, that this increment operator could be written like this, and also you could write this in this way. You could write plus plus before your variable, and it's going to be executed here and also give you the same result. You have 11. Okay, so this one is called the pre-increment, and this one is called the post-increment. But what is the difference between these two? Okay, I'm going to explain this using my example here. I'm sorry, there is something wrong here in my writing. Okay, so this is actually post increment, it's not pre-increment. Okay, post increment. You have a plus plus. Okay, I'm going to print it here. I'm going to make this increment operation within the same statement with the cout actually, and I'm going to print its result on the screen here. Then I'm going to printing the final result of a, just to make sure what happened. So let's run this. So I have this result. You see, this is a plus plus. Okay, when it's the same line actually. Okay, when I'm going to execute this, I have the value of the variable a as 10. It is still 10, but now I have it as 11 because the increment operation has been executed. So what happened here actually? Why this is not 11 here. Okay, this is because it is a post increment operator. Actually, the increment operation is going to be executed after this statement is going to be executed firstly. So this statement is going to be executed firstly, then the increment is going to be executed after this cout is going to be executed. So here I have it printed as 10, then it's going to be incremented, then it's going to be printed as 11. Now I'm going to take a screenshot for this. I'm going to use it. So now I want this. Thank you. Okay, you see. Okay, now let's get the other example. This is pre-increment now. And that's it. Let's run this. Okay, we have different result actually. Here the increment happened before the cout is going to be executed. Okay, and now you have it as 11 on the screen. Then to make sure it's 11 now. Okay, so that's the difference between the post increment and the pre-increment. This is pre-incremented actually. A is going to be incremented before this statement is going to be executed. So that's the difference. Okay, you see this difference. I'm going to make these adjacent to each other. You see the difference here actually. For the first line, the value of A is printed as 10. Here it's printed as 11 because this is incremented after the statement of the cout has been executed. So this is going to be 11 after this is printed, then now it's 11 here. But here A is incremented before the cout statement is going to be executed. It's 11 now, and then it is printed on the screen as 11. Okay, and to make sure it is 11. So that's the difference here. It's a very big difference actually for these two operations. Okay, actually I would like to note that it is not necessarily that you see the difference within the cout statement. No, any statement here actually, anything you are going to write here. Okay, the pre-increment operator is going to be executed on your variable before this statement is going to be executed, and also the post increment operator is going to be executed after this statement is going to be executed. So that's it. Okay, the same here. We have something called decrement operator. I'm going to copy this. This is called post decrement. It is the same, but it is minus minus actually. Okay, so I have decremented the variable b with 1 here. Actually, like I said, it is equivalent to writing b equals b minus 1. Okay, for this, for b minus minus, it's equivalent to this 4 actually. And now it is post. So I can say that I have 5 printed here for this, and now I have 4 printed here for this. Okay, so let's try this. So now I have what I have imagined a moment ago. I have b++. This line is printed as 5 for b value, and then I have b is printed as 4 actually. So it's printed as 4 because the decrement has happened after printing this line firstly. Okay, so that's it. The same applies here. You could make a pre-decrement operator like this. Let's run this. We have it as 4 4. Okay, 4 for the first line and 4 for the second line. So these are our decrement and increment operators. Okay, increment by 1 and decrement by 1, post and pre. Okay, so I think we have finished here for these also. Now we are going to talk about new type of operators, something called logical operators actually. So let's get to it. I would like to say that you are going to write something like this, and something like this, and something like this. Okay, actually these are the 3 operators for the logical operations on C++ variables or conditions actually. This is called logical not. This is a logical not. Okay, this is called logical and. Okay, and this is called logical or. So you have these three operators: logical or, logical and logical not. So this is and this is or, and this is not. Okay, let's take a look at our example: arithmetic operations or operators. I'm sorry, logical operators. So that's it. Let's copy this here. Okay, I'm going to explain this one by one actually. This is a logical not operator I'm going to use. Now I have declared, actually firstly I have declared 3 variables, a and b and c, 5, 10 and 15. Okay, now if I have something like an if condition or an if statement, okay, I have here, you know that you are going to write your condition here. I'm going to write something like if a is smaller than b, okay, then I'm going to print something on my screen here. I'm going to execute this statement. I'm going to print OK1 on my screen. So that's it. When I'm going to execute this, actually a is smaller than b, and it's true here. Okay, it's okay. But what if I have made this not true? Actually a is not greater than b, so I have nothing. Okay, I want to explain something before I'm going to proceed. Okay, any condition like this is going to be evaluated to something readable for this if. Okay, I want to explain something like, if you have something called logical 1 and logical 0. Okay, so let's remove this for now. Okay, logical 1 and logical 0. Okay, if I have something like this, I'm going to ask if a is smaller than b. Is this true? A is smaller than b? Yes, it's true. So it is going to be evaluated as logical 1 here. Okay, it's logical 1. And if logical 1, if our if condition has found that this or these brackets has the evaluation of its whole conditions as logical 1, so it's going to execute its code here, the code provided here actually. But what if I have written something like this? If a is greater than b and this is not true because A is 5 and B is 10. A is not greater than B actually, so it's going to be evaluated to logical 0, and if 0, there is nothing to be executed. So this is called logical 1 and logical 0 evaluation for the condition of the if or while or any statement that evaluates conditions. Okay, so this is going to be 0 actually. I would like also to denote something, okay, that you could write values here. Okay, what if I have written something like 1? So let's run this. I have okay 1 printed on my screen, so this is going to be executed. So these values are going to be allowed for this purpose. What happens if I'm going to write something like 6? Okay, I have the same result. So 6 here is going to be evaluated to logical 1 actually. Okay, it's like 1 logical, anything here is going to be evaluated as logical 1 for f. Okay, what if I have written something like -1? Okay, so also this value is going to be evaluated as a logical 1 for f. 6 -6. So this the same. Okay, any value like this. But what if I have written something like 0? So let's see. Nothing. I have nothing. 0 is evaluated as logical 0. Okay, so that's it. You have logical 1, any value, sorry, other than 0, but this is going to be 0. The logical 0 is logical 0, or the 0 is going to be evaluated as logical 0. And of course our conditions like A greater than B, that's going to be evaluated as logical 0, and so on. So this is a very important note actually. So now I'm going to explain our not. Okay, so let's see this here, our logical not operator actually. Now I have written this condition, which is A smaller than B, which is true, okay, which is could be evaluated to logical 1, but I have written not here. This not makes the whole evaluation of the if condition or the condition mentioned within the if bracket, that's going to be 0 right now. It's going to be not. So not 1, this is going to be evaluated to 1. So now I have not 1, which is going to be evaluated to 0, and this code is not going to be run, and I have nothing on my screen. So let's try this. I have nothing. But what if I have made this as greater than or something? Now this is going to be evaluated as logical 0. A is not greater than B actually, because A is 5 and B is 10, and this not is going to make this as logical 1 for f. Let's try this. I have okay 1 printed on my screen, so that's it. I want to show you something more. What if I have changed these numbers actually? What if I have made this like 20? So now A is greater than B, and this now is not true, but is going to be true. Let's try this. Yes, I have okay 1. So this is a logical not operator and its operation on our conditions. Okay, let's see something new, the logical AND operator. This is our logical AND operator here. Okay, it could be written like this, and this is a logical AND operator. Okay, and now it could be used to combine two or more conditions here. I have written my first condition here, and this is my second condition here. Okay, A is smaller than B and B is smaller than C. The AND operator works like if you are going to say that the first condition and the second condition, if these both conditions are going to be evaluated as logical ones, if this is going to be evaluated as logical one and this is going to be evaluated as logical one also, so now the whole evaluation is going to be logical one, so this code is going to be executed. But what if you have something different, like you have this evaluated as 0 or this evaluated as 1, so 0 ended with 1 is not going to be 1, is going to be 0 actually. So now if 0, this is not going to be executed. Also, if you have something like this is going to be evaluated as 1 and this is going to be evaluated as 0, and now 1 ended with 0 is going to be 0, so this code is not going to be executed. What if these both are zeros? 0 ended with 0 is going to be 0, and this code is not going to be evaluated actually. So let's get back to our example here. I have A less than B, then B less than C. These both are true because A is 5 and B is 10. B is 10 and C is 15, so this is true and true, so the whole evaluation is going to be true. So let's run this. Yes, we have OK2 printed on our screen. But what happens if we have changed something like this? We got nothing. Or this. We got nothing. Or both 0 and 0, we got nothing. Okay, so that's it. This is the logical AND operator. The next one is the logical OR operator. Let's talk about it. Okay, it's going to be written like this, these two characters here. It is the logical OR operator. Now I have two conditions here to evaluate. This is the first one and this is the second one. Okay, the OR works like if you are going to say that if any of these conditions are going to be evaluated to be 1, so the whole expression is going to be evaluated as logical 1. Let's see if this is going to be evaluated as 1 and this is going to be evaluated as logical 1 also. So now you have 1 ORed with 1, which is 1. Get it back. If we have 1 ORed with 0, you also have 1. If you have 0 ORed with 1, okay, you have also 1. But if you have 0 ORed with 0, 0 OR 0, logical OR, you have 0. So that's the only state when you got nothing. You got 0 here. Okay, so let's try this. Okay, here I have the first condition, A is smaller than B. Actually it's true, 5 is smaller than 10. And then I have B is greater than C, which is not true. I have 0 here. So now this is going to be evaluated to logical 1, and I'm going to have this printed on my screen. Let's try this. Okay, I have it. Now let's try to make the opposite here. Okay, this is not true, but this is true. Let's run this. I have it. Okay, it's very easy. Now let's make these both are true. Actually, A is smaller than B, and also B is smaller than C. Then I have it. Okay, let's make these both are not true. Neither A is greater than B, nor B is greater than C. So let's try this. Now we have nothing. So that's it. This is the logical OR operator. You see? Okay. Now we have finished all of these. Let's get to our additional content for this session. Yes. This was from session 2, the content of session 2. Okay. Now I'm going to session 3. Okay. We're going to explain about two things actually. Something called the relational operators in C++, and another topic that's called number systems. We are going to talk about the number systems. They are forming some basic step for many topics or concepts in programming. Okay, so let's get started for this. Relational operators. You have these relational operators actually. This is called equal operator. This is called not equal operator. This is called greater than operator, and this is called less than operator. This is greater than or equal operator, greater than or equal, and this is less than or equal. These are our relational operators. Let's get to our example here. I prepared this example for you. Now we have it. Let's work on it one by one. Okay. If we are going to compare two variables like this, okay, sorry for this. If you are going to compare these two variables, okay, like we have the same also, but we are going to change these values. A is going to be 5, B is going to be 5, and C is going to be 15. Okay, so now I want to compare A and B with the equal relational operator. This is the equal relational operator. It is written as equal equal. It differs from the equal operator like this. Okay, this could be used for assignments. I have assigned 5 for A. I have assigned the value 5 to be stored within the variable that's called A here. Okay, but this is not the same. It is a relational operator. It is the equal relational operator is used for comparison here between A and B, something like this. Okay, let's see how this works actually. If I'm going to make sure that A is equal to B, and if that's the case, I'm going to execute some code here. So let's run this. I'm going to make this just okay. I have printed okay on the screen because A is equal to B in our real world actually. But what if I have written C here? Does A equal to C? it's not true because A is 5 and C is 15. So now I think I'm going to have nothing. Yes, I have nothing here. I have no okay or something printed on my screen. So that is the equal relational operator. Okay. The next one is the greater than. Okay, like this. I'm going to check if A is greater than B or not. Actually, this is not true because A is 5 and also B is 5. A is not greater than B, so I have here nothing. You see? I have nothing. But what if I have used C here instead of B? Sorry, instead of A. Now I have C that's 15, and the 15 is greater than 5 actually. So I have OK printed on my screen. So that's it. Okay. Let's get one step back here. You remember that I have compared A to B, and it is not true that A is greater than B. But what happens if I have added something like this? I have added this equal here. So now this is not the greater than operator, it is greater than or equal operator. I'm checking if this value is greater than or equal to this value. You see? Now it is true. Why? Because I have used A and B. They are both 5 here, and now I'm going to compare them in this way. If A is greater than or equal, actually they are equal. Okay, so this condition is going to be evaluated as logical 1, and this code is going to be executed. Let's try this. Now we have it. We have OK printed on our screen here because A and B are equal now. But of course, when I use something like C, okay, it's also true because C is 15 and B is 5. It's greater. So I have show you that both greater and equal are going to work. Let's try something else. Get it back to A and make A like 4. Of course it's not true because 4 is not greater than or equal 5. So we have nothing here. Actually it is not the equal relational operator, it is greater than or equal. Okay. Now let's get back to our we have less than actually. This is a less than relational operator actually. Here I'm going to compare B to C. If B is smaller than or less than C, and it's true, so I'm going to see OK printed on my screen. Let's try this. Yes, it's true. Okay, but what if I have write A here? It's not true. But what if I have used the equal here? So now this is less than or equal, like the last example actually. Actually A and B are equal, they are both 5. So we have OK printed on our screen. Okay, and so on. So that's it. You see this not printing something, but this prints actually. You see? Okay. Now let's get back to our example and run this example. Okay, let's run this. Okay, we have okay. For this, the equal relational operator, I have A equal to B, so I have OK1 printed on our screen. Now this is not equal actually, relational operator here. Okay, if A is not equal to B, print OK2. Actually A is equal to B, so this is not going to work. Actually I have forgot to explain about this. This is called not equal. Okay, so now we have OK2 that's not printed on our screen. Actually there is no OK2 here. Okay, because actually A is equal to B. What happens if A is not equal to B? We have OK2 printed on our screen. Let's try. What happens if I have written C here? Actually A and C are not equal, so we have OK2 printed on our screen. Let's try this. Now I have OK2 from this here. You see? So that's it. OK2 is printed here because of this. A is really not equal to C. You see? Now we have the greater than. If A is C, if C is greater than B, it's true. So I have OK3 printed here. And then I have less than. If B is less than C, it's true. So I have OK4 printed here. And now I have greater than or equal. Actually C is greater than B, so I have OK5 printed on my screen. It's true. And also this is true because I have B is less than C, and I have used or equal here, so I have OK6 printed on my screen. So that's it. This is our topic about relational operators. Okay, so that's it. Now we have our number systems. Okay, so let's get to an introduction about the number systems actually. Okay. Okay. I want to ask you about something. What is the difference between a number and a digit? What's the difference between a number and a digit? There is a difference between these two. Actually, you could form or you could make or generate a number using some digits like this. I have this as an example. Okay, 7,000 and 456. This is our number here, our example number. Okay, this is a number. This whole thing, I can call it a number. Actually, this is a number, but each single character here within this number is called a digit. So the 7 is a digit. I have mentioned that this is a digit, and the 4 is another digit, and the 5 is another digit, and 6 is another digit. So when we have some digits adjacent to each other, now we have formed a number actually. So if you have a digit besides another digit, and so on, you have a number. Okay, so this is a number, and this is a digit. This is a single digit within it. Okay, so that's the difference between a number and a digit actually. Okay, let's get back. Okay, I want to mention two things to consider when working with a number system. You have some number systems to work with. Okay, number systems. There are two things to consider when you are working with a number system. There is something called base. Each number system actually has its base. Okay, each number system has its base, something called base, and when you know this base, you are going to know what are the allowed digits, okay, for this for this number system. What digits you are going to use within this number system when you are dealing with this system. What digits you are going to use for it? Okay. There is another thing that I want to mention. There is something called an order of a digit within a number. There is an order, okay, and this order makes you know or have the representation of the weight or the power of this digit within your number. Let's see something like this. We have this number, and each digit here has its order. Actually, this digit has the order of 0, and this digit has the order of 1, and this digit has the order of 2, and this digit has the order of 3. This is the order of the digits adjacent to each other. Actually, this is the order of the digit within the number. And when you know the order, you know its power or its weight within the number. This has the weight of ones, this has the weight of tens, this has the weight of hundreds, and this has the weight of thousands. Let's see this on action, or in action actually. I'm going to talk about the decimal system. Okay, let's start with our decimal system, the system we are using in our daily life. Okay, its base actually is 10. This is the first information to know. Its base is 10, so it has a base of 10. Okay, and now I can imagine the allowed digits for use within the system, for the decimal system. Actually, they are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are our allowed digits to be used within the decimal system. Okay, these are our allowed digits for us. Let's take an example like this. This is our number to be used as our example here. What about the order? Actually, I have a number that has 4 digits, so I'm going to write these orders for these digits. 4 has the order of 0, 5 has the order of 1, 6 has the order of 2, 7 has the order of 3. Okay, so that's it. So now when I'm going to form this number, when I'm going to form or make or generate this number, I'm going to write something like this. This is equal to 4 times the base, our base 10, to the power of 0. So 0 is its order here. It's like using this formula actually. I'm writing the digit, which is 4 here, times its base actually, which is 10. I'm in the decimal system, so it's 10 here. The base is 10, to the power of its order, which is 0 here in our case. Okay, so now I have written my first digit. I would like to say that this part is going to be called the power or the weight. Actually, 4 has the weight of 10 to the power of 0, which is 1. So this is the power, this is its weight within the number. Okay, so this is the weight or the power of this number, sorry, of this digit within the whole number. The second one is 5 times 10 to the power of 1 actually, so this is 50 now, and you see this is the power of 10. Okay, which comes from that you have your base to the power of its order, which is 1, so 10 to 1 is going to be 10. Now we have 6 here. This 6 is going to be 6 times 10 to the power of 2, and 7 times 10 to the power of 3, and that's it. 4 times 1, 5 times 10, 6 times 100, and 7 times 1000 actually. So now you got your number here. Okay, so that's it. It's for our decimal system. Okay, let's get to the binary system. It is the same actually. Now you know that your base, okay, is 2. I'm telling you that your base in the binary system is going to be 2, and your allowed digits, actually you could know that you have 0 and 1 as your allowed digits for this system. When you are going to deal within the binary system, okay, your allowed digits are going to be 0 and 1, and that's it. For example, we have this number, okay, 1110110, okay, with the same representation here, okay. These are the orders from 0 to 7 actually, and this is our number here. I'm going to form this number in the same way actually. I'm going to write something like this. The first digit is 0 times 2 to the power of 0. Then the second digit is also 0 times 2 to the power of 1. And the third digit is 1 times 2 to the power of 2. And the next one is 1 times 2 to the power of 3, and so on until I reach the last digit within this number. Okay, so here I have 0 times 2 to the power of 0, which is 0. Okay, I have something like 0 plus 0 also here. Okay, 0 times 2 to the power of 1, and then I have 1 times 2 to the power of 2, which is 4. I have here 4. Then I have 8 here for this. Then I have nothing, I have 0 here. Okay, then I have 32. Then I have 64. Then I have 128. So that's it. This is my representation of the number. It's going to be 236. This is this number. You see here that when I have made this formula, I have made this calculation. Okay, I have got my number represented in my decimal system. Why is this? Why this happened to me? It happens because you are using actually these powers, and these powers are going to be represented in your decimal system. You know the decimal system, okay, by nature. Okay, so you are going to represent your number finally in your decimal system, because these powers are going to be represented in your decimal system. So that's it. It's very clear actually. Okay, so we have our decimal system and our binary system. Okay, we have mentioned these two systems. Now I'm going to make some conversions. What happens when I want to convert from binary system to decimal system, and from decimal system to binary system? How I could achieve this? I would talk about this conversion. Okay, I would talk about these conversions, these two conversions actually, in the two directions, and you are going to know about it. Then when you face a situation like this, you want to convert between binary and decimal, or decimal and binary. Okay, you are going to do this in a moment. You are going to take a look at the number and know each equivalent within the other number system by sight. Actually, when you see the number, you could get its representation within the other system in a moment actually. But the way is like this. Okay, I'm going to write these orders here, I know about it. Okay, and I'm going to write the powers or the weights generated by these orders within this number system. Let's see an example. I have an example like this. I want to convert from binary to decimal. I have this binary number, okay, represented here. and I want to know what its value in the decimal system. How could I achieve this? I'm going to write these two lines, okay, these orders 0, 1, 2, 3, 4, 5, 6, 7. Now 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, 2 to the power of 6 is 64, and 2 to the power of 7 is 128. Okay, now I have my number here, like 1, 1, 0, 0, 0, 0, 0, and 1. I have forgot to write 1 here actually. Okay, so this is my number. I want to get its representation or its value in the decimal system. How I could achieve this? I am going to look at these powers. Actually, I have 1 here and 8, then I have 64, then I have 128. So let's get to this. Okay, it's pretty easy actually. Let's get the summation of these numbers. Okay, 64 plus 8 is going to be 72 actually. 72, and this is 100. So I'm getting something like, I have this plus this plus this plus 1 at the end. Okay, so I think it's going to be 201. Okay, yes, it's true actually, because we have this as 72 and this as actually it is 200 now and 1, so this is 201. Yes, that's it. Let's make sure about it. Okay, we have 128 plus 64 plus 8 plus 1, and that's it. Okay, let's get to our programmer view to make sure also if we have a binary representation of 0, 0, 1, 0, 0, 1. Let's get it. It's a decimal representation. It is 201. So we are right. Okay. Now the reverse operation, convert from decimal to binary. Okay, we have an example here. What if you have something like 101? This number I want its representation in binary. Okay, I want it's a decimal number actually, and I want its representation in binary. So let's see what you are going to do. I'm going to write the same two lines. It is a reverse operation, but we are going to use the same way in the reverse order. We have these two lines, order and weights, okay, written here, and I want to represent 101. So I'm going to ask myself a question: what is the biggest number that could be subtracted from this number? What's the biggest number that could be subtracted from this number? From these, actually. Of course, this couldn't be subtracted from this, but this could be subtracted from this. Okay, so let's do this operation. Okay, now I have 101. This couldn't be subtracted from this, so I'm going to write 0 here. But this could be subtracted from this number, so I'm going to write 1 here, and now I have 100 minus 64, okay, which is going to be uh, uh, which is going to be something like this, 37 actually. Okay, so now I have this number. Okay, 37. What is the biggest number of these that could be subtracted from this number? Now I have this. It could be subtracted from this number, so I'm going to write 1 here, and I'm going to subtract, so I get 5 actually. So now what's the biggest number that could be subtracted from this number, from these numbers? Okay, what is the number that could be subtracted here? I think it's 4. Okay, so 0 here, and 0 here, and 1 here. Now I get 1 actually after subtraction. What's the biggest number to be subtracted? Okay, now I have 2 and 1, and of course 1 is going to be subtracted here. Okay, so now we have 0, and now we have 0 here and 1 here. So that's a binary representation of this number, which is 101. Okay, so this is 0 1 1 0 0 1 0 1. So that's it. Okay, let's make sure actually we have something like 101. So that's true. Okay, you see, this is true actually. So that's it. This is how you could convert from decimal to binary. Now you know all of these about number systems. I think we have finished for today, and we are going to meet on our next session. Thank you so much.